Assalamualaikum and hello. My name is Nurkamala binti Yusri, and today I would like to present about the progress of my FYP project, which is the development of solvent derived from fresh and matured seeds of moringa alifera as wastewater treatment agent. My supervisor is Dr. Hidayat Aini, and also my co-supervisor is Dr. Wan Salida binti Wan Mansur. This is the overview of my progress presentation, and I'll start with the research background. Why water pollution occurred? Water pollution is such a serious problem today because our lakes, rivers, and oceans are mostly contaminated and toxic. This is occurred because of some reason, and one of them is because of the natural disasters such as tsunamis and floods. Mostly people in rural areas they have no other choice rather than to drink and use and purify water for their daily life. So we have the conventional wastewater treatment such as aluminum sulfate, but it is quite risky because it can harm our health, and also it is quite pricey. So that we have come up with the other solution, which I use the natural absorbent for purify the water. For example, in my FYP project, I will use the moringa alifera. But why I use moringa alifera? Because it is very easy to obtain and low cost. Baptista et al. At 2017, he also stated that moringa alifera proteins and globulin presented the best performance, promoting high turbidity and color reduction efficiency in low turbidity waters. This is the problem statements for my FYP project, which is the idea from this project is to produce adsorbate from mature and fresh seeds of moringa alifera, but in a sachet form. This is the hypothesis of my project, which is to produce the adsorbent that are predicted to be effective in removing contaminant in the wastewater. And this is the scope of my study, which is we will mix the samples, which is the seeds, with the sulfuric acid and then heated in the furnace and oven, and then the effectiveness of the sample then will be measured using the turbidity meter and UV spectroscopy. But at the end, we use the FTIR, DET, SRD, and SEM to determine the physical and chemical characterization of the sample. This is the research objective, which is to prepare the adsorbent, to determine the effectiveness of the adsorbent, and also lastly to analyze the physical and chemical characterization using these instruments. This is my literature review, and this is my methodology. First, I prepared the matured and fresh seeds of moringa alifera for chemical activation, which is I dried the seeds under the sunlight and oven, and then I prepared the adsorbent by mixing the seeds with the H2SO4, and then I prepared the synthetic wastewater sample by using kaolin and methylene blue, but unfortunately we cannot proceed with the methylene blue. And then I tested the effectiveness of water treatment analysis using for kaolin wastewater using turbidity meter, and lastly I did the sample prioritization using SRD, FTIR, SEM, and DET. And DET also cannot be proceeded due to some situation. This is the rough method, which is for the objective one, which to prepare the adsorbent from the seeds. Then I dried it in the sunlight, and then I further dried in the oven, and then the samples were grinded and sieved. And this is to produce the adsorbent, which I mix the seeds with the H2SO4 or sulfuric acid, and the impregnation time was set for 2 and 4 hours. And then the samples then will be heated in the hot oven and then further heated in the furnace. This is the ratio of weight of the seeds and volume of the H2SO4. This is the main element to produce the adsorbent. And then the second one is to prepare the synthetic wastewater sample, which is the kaolin wastewater I mix kaolin, 10 gram of kaolin with the 1 liter distilled water, and then I stir and sit the kaolin for 24 hours. To test the effectiveness, I took 0.1 gram of the matured and fresh seeds and tested in the 10 milliliter of the kaolin wastewater, and then I took the initial NTU reading and final NTU reading for the experiment with 5 minutes time interval, and then I calculated the average of the reading. This is the equation for percentage stability removal. This is to analyze the physical and chemical characterization, which I use the FTIR, SRD, SCM, and also BEP. This is the results for my final project, which is the first one. This is the dried seeds, and then I grind it and sieve it become powdered. And to produce the adsorbent, I mixed it with the H2SO4 or sulfuric acid and a filter, and then I put the samples into the oven and furnace, and then it became like this. This is the adsorbent, and then I divided into 2 gram, 4 gram, 6 gram, 8 gram, and 10 gram. This is the objective 2. The result for objective 2, which is to determine the effectiveness using turbidity meter. This is the table for mature adsorbent seeds for 2 hour impregnation time, and this is the mature absorbent seeds for 4 hour impregnation time. You can see here that there are the higher the ratio of the seeds and sulfuric acid, the higher the turbidity removal. It likely I will show you this is the fresh adsorbent seeds for 2 hour and fresh adsorbent seeds for 4 hour. For better visual, I will show this graph. This graph this graph showed that the fresh adsorbent for 2 hour impregnation time has higher turbidity removal compared to the mature adsorbent for 2 hour. And then the fresh adsorbent for 4 hour also has higher turbidity removal compared to the mature adsorbents for 4 hour. So it can be concluded here that the fresh for 4 hour and 2 hour impregnation time are more effective compared to the matured for 4 hour and 2 hour. Next, we will move on to the objective 3, which is to analyze the physical and chemical characterization of using FTIR, SRD, SCM, and BEP. This is the FTIR KBR, and we can see here at the 3450.53 per centimeter. This is the figure 2 here showed the matured seeds of raw and adsorbent, and I will touch only the matured for adsorbent 2 hour and 4 hour. You can see here at the 3450.53 per centimeter, it was assigned to C double bond COH, which is the alcohol group that appears in the protein and fatty acid structures in Moringa oleifera seeds. At 1636.71 per centimeter, it also was assigned to C double bond O, which is the carbonyl group that can be found in the protein and fatty acid structures. And lastly, we have 1122.51 was assigned to CO, which is the CO stretching, which is from ester group. And for matured for 4 hour impregnation time, there are no peaks to be observed here. This is because the hydrolysis effect due to the use of H2SO4, and this resulting in the decomposition and subsequent release of their byproducts as a volatile matter. Then I will show you the fresh moringa seeds. It also showed the same trend, which is the fresh for 2 hour impregnation time at 3444.78 per centimeter, showed OH functional group, C double bond O at 1628.11 per centimeter, and CO at 1122.31 per centimeter. Hence, I will move on to the matured moringa seeds. This is the matured moringa seeds for absorbent and raw. We can see here that it showed that the SRE is to assess the presence of crystalline phase in natural materials, and this graph showed that they are amorphous in nature. The fresh moringa seeds also showed the same trend, which is indicated that they are amorphous in nature. So this is the SCM of scanning electron microscope results. We can see here that for matured raw moringa oleifera seeds, there are no pores to be seen and they have more irregular surface. But when we activate using H2SO4 for 2 hours, they are more porous and large surface area. And after we increase the impregnation time, it has the high porosity and larger surface area and high rate of absorption. This is the same as the matured one, which we can see that the fresh has high porosity and larger surface area. For discussion, it is the brief description that I explained before. And for conclusion, for impregnation time, absorbent with 4 hours impregnation time in H2SO4 is more efficient in removing turbidity emitter compared to the 2 hours impregnation time in H2SO4. From the results, it has proven that fresh absorbent moringa oleifera seeds is slightly more effective because it shows high turbidity removal, as I shown in the graph, in both 2 and 4 hours matured absorbent moringa oleifera. So it can be concluded that matured and fresh moringa oleifera seeds are suitable for turbidity removal for wastewater treatment. And this is my Gantt chart. I have done my writing submission and proposal presentation, my objective 1, my objective 2, and also objective 3. Data analysis is 80% done and thesis writing is 60% done. The thesis submission will be held on June. This is my references, and thank you for your attention. Thank you, Doctor. Thank you.